Can we start? Yes.
Good morning, sir.
Good morning, sir.
Start? Good.
Sir.
Yes, right. Good. We are now talking about left straight, correct? So we have completed this slide. Yes or no?
Yes, sir.
This one?
No, sir.
Yeah. You see, right, good. So left straight, I have told you there is a reduction in temperature when you increase the altitude. So this process is basically called, we can say, yes, this fact I can say, it is called a left straight, right? So when you increase the temperature from one point to another point, so it is basically with the altitude, then of course temperature reduces. But here, if you have a look at it, so this atmospheric layer, you see, we can take troposphere. There are different layers available, but this scenario is particularly specific, I can say. It is specific for a particular layer. So we will discuss that one later, right? So this is left straight. Then, of course, we will talk about adiabatic cooling. You know, this is also very, very important. You know, the process of adiabatic heating. You can change the temperature from one point to another point, but there is no heat loss, okay, between an object and its surrounding environment. If you have that scenario, that is basically called adiabatic cooling. You got the point? Isothermal, it is very different. We will discuss that one later, but this adiabatic cooling is highly essential for us to understand certain processes that are involving in the formation of clouds. You understood? So here I have put one point here. You simply read this. Air under lower pressure expands, and this expansion causes the temperature to decrease. Right? This is adiabatic cooling. You got the point? So here what we do is that, you know, when you reduce the temperature, you see this direction, right? 30, 20, 10, right? It expands. As it expands, it cools, right? So this is the normal procedure, okay? You can see the changes with the altitude, right? You see, when you compress the air, it warms, right? It is actually, you know, it is happening. Then we can simply see the temperature profile, this direction, 10, 20, 30. So when you are coming from this point to that point, air is compressed, then you can say it warms up, right? So here, this direction is opposite to this. When you expand this one, it usually cools, right? Then, of course, we will go for the condensation process. Then there's a possibility for us to have raindrops formed, right? So this is the basic process behind adiabatic cooling. You got the point? Yes or no? Students?
Yes, sir.
Yes, please make a note on this. Abhishan, finished? Yes?
Yes, sir.
Right, we'll see this. There are some points for your reference, right? When unsaturated air at or near the Earth's surface is carried to higher levels, either through convection or through expansion. You see? So this is the major point. I can just connect this one to that one, right? Because you should, yes, we'll see this, right? Mm, yes, you see this sentence now. When unsaturated air at or near the Earth's surface is carried to higher levels, either through convection or through expansion, expansion will occur due to the reduction of pressure of altitude. You got the point? Expansion, we have seen that one just before. You know, expansion, this is compression, this is expansion, right? So this is basically happening with an increase in altitude. That is the first point, right? This expansion is adiabatic. That means no any heat is added to the air from the outside sources and none is subtracted from it. I have told you, when you change the temperature, there is no addition or subtraction, right, of energy from the system. Therefore, we label it. How do we label? Adiabatic process, right? So that is the second point. However, the temperature of the air mass is lowered since heat energy is transformed into kinetic energy in the process of expansion. So what is happening when we expand? You know, molecules are getting separated, right? They are expanding. So this is developing a motion inside the system. If you have molecules moving here and there is a possibility for you to have velocity profile. So it creates kinetic energy, right? That is of course very important for you to understand, right? This reduction in temperature is adiabatic cooling or dynamic cooling. When you reduce the temperature, of course, we can say that process is called adiabatic cooling. You understood or not? Manasi?
Yes, sir.
Right. Please make a note on this. Shamina, finished? Shamina, are you available? No?
No, sir, she is absent.
She is absent today?
Yes, sir.
Okay. Abhishan? Abhishan, today also, you know, so how many? So we have got, yes, more than 14 students absent, right?
Yes, sir.
So I just want to ask you one thing. Yesterday we had a meeting. We are planning to have online exams, right? Are you all happy to have online examinations? Please talk to me. Abhishan,
Yes, sir.
are you happy to have online exams?
So we don't know about the procedures. So,
Yeah. First, yes. So we will circulate you the procedures because we are planning to have quiz exams. Yes. You know, that is also important. Are you happy to do quiz exams through online system? You know, the first condition is that you all should have 2 smart devices. Is that possible? Students, please talk to me. Students, can you please talk?
Sir. Sir.
Yeah.
Sir, please explain the previous sessions for the newcomers.
Yeah. Yeah. Okay, we will do it. The thing is that Abhishan, I requested Shamina to. Shamina is having certain issues today.
Yes, sir.
What is that?
She is not well, sir.
Okay. I mean, this is a bit pathetic because every time 14 students they are absent. So we have to fix this problem. It is due to their personal issues, so they are deliberately cutting classes. Midushana, yes, are you available?
Yes, sir.
Yeah, you are representing another group, am I right? Abhishan is in one group, you are in another group, am I right? So,
Sir.
yeah, what is the problem with your friends?
Sir, Samina is representing another group, sir.
You are not representing that group?
Yes, sir, I'm not.
Okay. I'm just asking you as a member of this batch.
Yes, sir.
Students, please talk to me. Otherwise, I will take my responsibility. Then, if I schedule that examination, you have to answer. If you are telling nothing, okay, it means that you all accept my instruction. Then I can go with that. Are you happy to have it? Are you understanding agricultural engineering difficult?
Understandable, sir. Understandable, sir.
Understanding. Good. That is the good point. Practical, how do you feel?
Yes, sir, we understand.
Understand.
Yeah, understood.
Are you recording your practicals properly?
Yes.
Yes, sir. Yes, sir.
Yeah. The thing is the thing is that if we are unable to conduct, or if we are having certain classes missed, I can say you this one. Okay, if you are having certain problems, if you are having certain issues with our system, you first talk to us, right? You just talk to department people first. You got the point?
Yes, sir.
I mean, Abhishan, if one class is not happening, right? You just talk to me, or you just talk to HOD, right?
Okay, sir.
Last time you didn't have that practical, yes or no?
Yes, sir.
Yeah. Then what did you do?
So we called Prabhan, sir, but
Yeah. Then what did you do? He did not answer. Yes.
yes, sir.
Yes. Then what did you do? Abhishan,
Yes, sir.
can you please talk to me?
Yes, sir.
After that, what happened?
We called Venugopan, sir.
Yeah. That is the tricky thing, So, if something is associated with our department, please talk to department people first, right?
Okay, sir.
Yeah, here, no? So then, that message came to me. Then, it's a bit tricky. Okay, please, in future, you are not knowing the real procedure, right? If one thing is not happening, you first talk to the department people. Then you just go to your plan B, right?
Okay, sir.
Okay, good. So tomorrow, what about your practical? Has it been confirmed?
Not yet, sir.
It has been confirmed?
Yes, sir. Samina will call to sir.
No, will, because, we have got 24 hours,
Yes, sir.
less than that. Has it already been confirmed, or you are going to confirm it?
I think not yet, sir.
Yeah. Abhishan, Shamina is absent today. What you can do is that, yes, you just get it finalized. You just talk to me this evening, okay, about
Yes.
your arrangement, right? Then if it is not happening, then I will have a chat with that person. Then of course we will make an arrangement to have your practical tomorrow, right? So we are starting engineering drawing, right? It is very different from this practical. I mean applied hydraulic. You got the point?
Yes, sir.
Yes. One more thing. I'm going to ask you two things. One, your attendance. Second one, so if I want to schedule quiz examination through online systems, so are you able to have two smart devices? Students, please talk to me. I'm here to help you, right?
No, sir.
One,
No, sir.
No, sir.
one desktop,
No,
one
sir.
laptop.
No, sir. No, sir.
No, sir.
You are not willing to have, no?
Yes, sir.
Yes, sir.
Okay. Yeah. Then we'll see, right? Because time is moving very quickly, so we have to complete everything. Then we have to keep you updated with your results. Then only you can select very good departments, right, for your better future. Other departments, other batches, right? Your seniors, they are going to have the quiz. Quiz exam. They are going to have their mid semester. Again, they are going to have their final exams through online systems, right? Some budgets, they agree to have it. We are trying to expand that system for all other budgets. If it is possible, that is applicable for you all as well. But you are expressing your, yes, unwillingness to do that. Yes or no? Students? Manashi, are you happy to have online exam?
Yes, sir, but some of our friends don't have the facilities that are required to have.
Yeah, I agree. Yes. At the
That is
same
the
time,
problem.
when you are doing, that's the problem. I can understand that. When you are doing your examination, you have to keep your camera on all the time. 2 cameras. Is that possible? Then, of course, you have to have backup power system. I mean, if you are having certain disconnections, of course, you should have a backup system. Is that possible? No? Students?
No, sir.
No, sir.
Yeah, then we'll see. Yeah. Okay. Then I will convey this message to the examination committee, right? Then, of course, yes, we'll see what they say, right? Okay. Please get ready for that. However, we will have certain assignments, right? I'm going to expedite this process. We will have certain assignments. Then, of course, that is useful for your final evaluation. Yes, Abhishan, I requested Shamina last time just to fix this issue. It is still questionable. What is that?
Is it?
Number, right? Today we have got 133, around 10 students, more than that. Okay? Absent. You see that statistics? Yes or no?
Yes, sir.
Abhishan, you please talk to your friends and let me know what they say, right?
Okay, sir.
We have got some new students today. Yes or no? Tell me that one.
Yes, sir.
New students? How many? Abhishan?
Sir, in the weekends, 3 students contact me.
Yeah, they are available today.
I think yes, sir. But yeah, available, sir.
Could you please introduce yourself?
Yes, sir. I am Siddharth Mimante.
Sorry? This is your first AEN class, yes?
Yes, sir.
Right. Okay. You are from Ratnapura, yes?
Yes, sir.
Yeah, right. The second one?
I am Abdul Wajid from Balapitiya.
Right. Okay. Another one? Available? This is the problem. Please, I mean, newcomers, this engineering is very interesting. I had a chat with your friends. Okay, we are having very good collaborations. We are going to update the system in future. So you are welcome to our department to work with the different projects. Then of course you will be having very good jobs. You will be having very good degrees. You will be having your postgraduate qualifications, right? For that, you should develop your capacity. So from your initial point, you have to work very systematically just to reach your final target, right? So that is very, very important. Therefore, we are treating you all very systematically. This is a bit pathetic because, you know, we are having this virtual mode. It is a bit complex for us to have very good relationships. However, we are trying our best to do that, right? Another important thing is that we are having new students every day. We are going with the different concepts, different practicals. Of course, it's very hard for them because we are introducing some technical terms. As a batch rep, Shamina, today Abhishan, your responsibility is to convey their difficulties. I mean, newcomers' difficulties. Then only we can organize some additional classes just to cover the sections that have already been completed. You got the point? Yes or no?
Yes.
Abhishan, please do it because new students will be suffering from this system. Then, of course, it's not good for us to, you know, make them very stressful. It is important. You can feel this one when you are having your exams, right? So it's a bit tricky. Okay. Newcomers, please talk to your batch rep. Then please convey me your difficulties. Of course, I will organize certain additional classes. Then you can follow sections that have already been completed. You got the point? Yes or no? Newcomers, can you do that?
Okay, sir.
Okay. Right. Satkunalingam, department students are available today. Everyone
Yes,
is
sir.
present.
Yes, sir.
Everyone is present. No one is absent.
Yes, sir. Yes, sir.
Okay. Yes, department people, you also talk to me if you get some difficulties, right?
Okay, sir.
Okay, okay, good. Right. With that note, I am finishing this part, right? So this is simply, yes, this is simply the end. You can just refer this one. If you get some clarifications, you can talk to me later. Yes, you have studied interception, yes or no? You completed? Sahitya completed this one. Yes or no? Please talk to me.
Yes, sir.
Yes.
Yes, Sahitya completed interception. Today I will start runoff, right? So it's a very important part because we will be having certain discussions. And of course, these discussions are very, very important, right? Runoff, I have already given you the introduction. I'm going to discuss some critical points that are related to runoff process. Your responsibility is to understand such processes comprehensively just to analyze certain critical problems. So that is, of course, your part. You should work on that. Then, of course, you can develop your comprehensive knowledge just to analyze complex scenarios, right? With that small introduction, I'm just touching this one. Here, we are going to discuss certain key processes, right, that are related to runoff. First, we will define that one. We have already done that. Then, of course, we will talk about types. Then, of course, we will talk about factors that are influencing runoff process. Then, of course, we will talk about measurements. Okay, measurements of runoff. So we will see. Then, of course, we will study a particular method that is called rational method. Okay, to calculate peak runoff. So we will discuss that one. These are basic points that are related to this concept, right? Yes, with that note, I'm just moving to the introduction. Runoff, I have already told you, it is the process of the surface flow of water, right? It is possible when we have enough precipitation, and that precipitation, I mean amount, is greater than the amount that is infiltrated vertically into the soil profile. You got the point? You see, runoff means the draining or flowing of precipitation from a catchment area through a surface channel. So it is very common. It is happening over the soil surface. For a given precipitation, the evapotranspiration, initial loss, infiltration, and detention storage requirements will have to be first satisfied before the commencement of runoff. I have already explained. So what I can tell you is that you can simply see, okay, this is the surface, right? So we are having this precipitation. I have already explained this is X, we say, millimeter, right? So here we can say this is of course infiltration, we can say Y. Then I can say this is the evaporation, you can say, okay, Z. Then you can say this is transpiration, you can say this is P, right? So when you talk about this one, this amount, when you are planning to have this runoff amount, that is, we can say Q, right? When you are having this amount, of course, you can say this amount, okay, that is X. This X should be greater than this one, and this one. You got the point? We add this one, evaporation, transpiration, then of course, infiltration. Sometimes if we are having certain tanks on the surface, small depressions, of course, little amount of water will be stored there, right? So this amount will be subtracted from this amount. Then of course, if you are able to meet all these requirements, this is basically through precipitation, that is through X, right? There is a possibility for you to have this Q, which is happening over the soil surface. You understood or not? Difficult?
Understood, sir.
Yeah, good. So this is of course runoff. So we are going to study this one in detail, right? For a given precipitation, the evapotranspiration, initial loss, I have already included everything, right? When these are satisfied, the excess precipitation moves over the line surface to reach smaller channels. So that is very, very important. Channels are waterways, okay? Usually they are having some land boundaries, okay? Of course, this is of course happening over the soil surface. Then we will see this dynamics when you are coming to the second semester of the second year, right? So we will study that one in detail, channel dynamics, right? So that is important for you to understand certain processes. So this is the basic concept behind runoff, right? Please make a note on this. Midushana, finished?
Sir, I'm writing.
Okay. Sarpunalingam?
Still writing, sir.
Okay. Manashi,
Yes, sir.
you finished?
Yes, sir.
Can you please explain this process?
Yes, sir. Runoff occurs when the precipitation is greater than
Yeah.
evaporation, transpiration, and infiltration.
Yeah.
So the excess water will move through in the land surface to reach the smaller channels.
Yeah, good. So this is of course an introduction for the process called runoff, right? Mayuri, finished? Mayuri?
Yes, sir. Yes, sir.
Okay, finished?
Yes, sir.
Okay. Shamira, finished?
Yes, sir.
Yeah. Makeshika, 025.
Yes, sir.
You finished?
Yes, sir.
Right, good. So with that note, we will move to the next point, right? As rain continues, right, soil becomes saturated and the infiltration capacity is reduced. Then the overland flow starts as runoff. You got the point? So this is the very important point. So we have to understand this one properly, right? This is the surface. I have told you we have got soil particles. Okay, so there are particles, right? You see there are soil particles available. So this is the bedrock. So we can say this is the bedrock, right? We can say this is the bedrock. So from this we can have this soil particle. This is basically through the process called soil genesis, right? So now when you have these particles organized just below the soil surface, there is a possibility for you to have gaps. These are basically gaps, right? Okay, this is this is between soil particles, right? So here when you grow plants, their root hairs will be moving through these spaces. We will be having different organisms. Say example, some organisms are having symbiotic relationship. The example, nodular bacteria, right? So it is of course symbiotic. Both organisms are getting benefits. That is symbiotic relationship. Some are of course antagonistic. It is of course problematic because one party will be getting benefits and the other party will be suffering from certain difficulties. So it is of course problematic. Then you have already studied when you have enough precipitation, water will move. Before the movement of the water into this space, of course this space had been occupied by air. You got the point. So when you talk about the movement of the water into this, before that movement, usually we can say this is filled with air, right? As this water moves into this one, we can simply say this air will be replaced and all these pores, right? I mean, yes, I can say will be filled with water, right? So when you complete this filling, you can say this, yes, you can say this soil has been saturated, right? It means there is no air, right? If you are sending more water, then of course, if this one is saturated, then of course this one will go over the soil surface. That is runoff. You got the point? So we will see these dynamics later because I have already discussed about rhizosphere, right? So plants' roots are very active in this region because we are having three types of water. Soil water, I can say, capillary, gravitational, and hygroscopic, right? So there are three types. So we will talk about capillary water because that is readily available for plants to grow, right? We will see that later when we are talking about irrigation, right? So here what I want to say is that when you send the water into this system, it is important for you to confirm that this system has been saturated just to have this overland flow. If you are having certain pores here, if they are still to be filled, of course, the precipitation will move vertically just to fill this one. Okay, that is very, very important, right? If you talk about this one, there are different types available. If you consider runoff, if you have water flow over the soil surface, that is surface runoff. If it is happening just below the soil surface, okay, that is called subsurface runoff. If it is happening at the bottom layers, that is called base flow. So we will talk about all these later, right? So I will explain that one in detail. Please make a note on this. Which one finished?
Yes, sir.
Right, good. So we'll see this one, right? Subsurface runoff. This is also very, very important for us to understand, right? The portion of rainfall which enters the stream immediately after the rain. You got the point? The portion of rainfall which enters the stream immediately after the rain. I mean, it occurs when all losses is satisfied and, surface runoff, right? It occurs when all losses is satisfied and rainfall is still continued and the rate of rainfall is greater than infiltration rate. You got the point? I have already discussed all these. This is first type. What is that? Surface runoff, right? So this is the surface runoff. Please make a note on this because we have already discussed this one. Midushana, finished?
Writing, sir.
Yes, finished?
Writing, sir.
Okay. Kirunsika, you finished?
Yes, sir.
Kirunsika, are you understanding agricultural engineering difficult? Applied hydrology?
I am understanding, sir.
Okay, good, good.
Thank
Anuja, you understood? Zero 05. Yes? Yes. Anuja, is it difficult for you to talk? Okay. Right. Okay, fine. Yumi finished 049.
Yes, sir.
You are understanding applied hydrology very
Yes,
nicely. Yes.
Yes, sir, I understand.
Okay, good. Right. We'll see. This is of course subsurface runoff, right? This is very important. You know, I have already explained that one. So we have studied the hydrologic cycle, right? The part of rainfall which first leaches into the soil and moves laterally without joining the water table to the stream, rivers, or ocean is known as subsurface runoff. You got the point? So this is precipitation. I have told you. You know, this is of course we will see. So when you talk about water table, I have told you, right? Water table is very tricky for you to understand because we will study that one in detail later, right? You know, here usually just below the soil surface, we will be having some rock layers. Okay, inside rock layers, of course, there is a possibility for us to have water stored, right? And you know, when you talk about the soil zone, and again these layers, there are two types. One is called zone of aeration, other one is zone of saturation. So this saturation is having water, right? Then if you consider the upper boundary of the zone of saturation, that is called water table. How do we call it? What is water table? That is the upper boundary of the saturated zone, right? So here, what I want to say is that this subsurface flow is happening, right, before the water is touching the water table. You got the point? Yes or no? So this is of course upper boundary of the saturated zone. Usually when you have infiltrated water into this, it moves to this direction. This is called subsurface flow, but this one is happening inside the soil. It is not over the soil surface. You understood or not? Yes or no? Because of this, yeah, because of this slope, right? It is moving into this water storage system, right? So it is happening. If you are able to have this process, that is technically called subsurface runoff. Okay, please make a note on this. Vidusha, finished?
No, sir, writing.
Okay. Satkunalingam, finished?
Writing, sir.
Okay. Please tell me names of public officers. First one, Satkunalingam Premnath. First. Second one,
Ganesalingam Nirojan.
Nirojan. Yes. Only two?
Prabhurna Sivas.
Sorry?
I am Prabhurna Sivas.
I'm unable to hear you. I'm sorry.
Prabhurna Sivasudan.
Okay, good. Only three, no? 3 or 4?
3, sir.
Okay,
Three, sir.
right. Okay, good. Premnath, finished?
No, sir.
Okay. Abhishan, finished?
Yes, sir.
Okay. Abhishan, can you please define water table? What is that?
It's upper boundary of the saturated zone.
Yes, good. Upper boundary of the saturated zone. Right. Midushana, can you please explain the process of subsurface runoff? Midushana,
Yes, sir.
can you please explain? Difficult?
It's something difficult, sir.
Okay. Right. Then I will ask Pumi, can you please explain 049?
Yes, sir.
Can you?
Difficult.
Okay. You have to be smart, you know. This is for your development, no? Yes. Vidusha, can you?
Difficult, sir.
You are not, yeah, you have to try, you know. Okay. Nayaka 054.
Yes, sir.
Can you explain subsurface runoff?
Difficult, sir.
Okay. Navodi 058. Can you explain? Sorry?
Sir,
Can you?
it's happening. Sir, can you hear me?
Yeah. Can you explain?
I try, sir.
Yeah, good.
It's happening because of the precipitation. The soil.
Yeah, go ahead. So you can say, okay, precipitation, it is moving into the soil surface, but it is not touching the water table, right? Before that, it moves laterally to touch water storage systems. So if we have that flow inside the soil, just below the soil surface, we can say, that is called subsurface runoff. You understood?
Yes, sir.
Yes, good, right. Manashi, can you explain?
Yes, sir.
Yeah.
The precipitation water will be infiltrate into the soil surface.
Yeah.
And the subsurface flow will happen when the water will move laterally without touching the water table, and this water will go to the streams, rivers, and the oceans.
Yeah, very nice. Yes, this is, of course, what is this? This is subsurface runoff. Very simple. Everyone should explain. That is my expectation. Yes, please try your best, right? I have told you this one. If you are staying at a point, no improvement. If you try to walk, then there is a possibility for you to have good development, right? That is my suggestion. But you know, you can make your own decision, right? Fine. So then we will talk about this base flow. So there are three types we have already studied. This is base flow. You see, it is delayed flow, defined as that the part of rainfall which after falling on the ground, we can say surface, infiltrated into the soil, okay, and meets to the water table and flow the streams, ocean, etc. You know, this is, you know, touching the water table. Subsurface flow without touching the water table. The movement of water in this system is very slow. We will see that dynamics later. Therefore, it is also referred, how do we call it? Delayed runoff. How do we call it? This is delayed runoff. So this is very slow. After the precipitation, it is infiltrated into the soil profile. Then it is touching the water table. Then it flows laterally because of the permeability. We will see that one when you are coming to the second year, right? Permeability. Then, of course, because of very low permeability, this flow is very slow, right? However, it is happening because of this slow movement, okay, of the lateral flow, right? We simply label this one. How do we label it? This is called delayed runoff. Please make a note on this. Vinujan, finished? Vinujan, can you hear me? Are you 090? Are you available? Can you hear me? Yeah, can you explain this base flow? Difficult? Okay. Please try to develop your capacity to just explain this one in future, right? Okay, good. Lakiru 0900395. Can you please explain this base flow?
Difficult, sir.
Okay, difficult. 103. Can you please explain?
Yes.
Sorry?
Yes, sir.
Yeah, difficult.
So can you hear me?
Yeah, I can. Yes, please explain. Yes.
This is the third type of runoff. So it takes place. It is a slow process. So once
Sorry, your voice is not clear. Can you please make it clear? Difficult?
yes.
Can you please talk to me now?
Yes, sir. 1 second.
Yeah. Yes, explain.
So,
Yeah. You explain. Yes.
so this is the third type of runoff.
Yeah.
So it is a slow process.
Yeah.
So once the precipitation touches the soil and it gets infiltrated, and after the infiltration, the water gets to the water table, and the water moves laterally to the streams and oceans.
Good. Right. So this is the slow process. Therefore, we are calling this one. How do we call it? Delayed runoff. Right. Good. So with that note, we will move to the next one. Right. So we will see factors affecting runoff. We are going to discuss all these factors systematically just to understand the process. Right. We'll see. Runoff rate and volume from an area are mainly influenced by following two factors. First one, we will talk about climatic factor, right? Climatic factors, there are different types. We can talk different sub-themes under this. First one, we will talk about rainfall characteristics. You should have studied missing data analysis before. Yes or no? Manasi?
Yes, sir, in the practical session.
Yeah, have you studied Thiessen polygon method,
Yes, sir.
arithmetic mean method? Yes.
Yes, sir.
Yeah. So please, you know the difference between rainfall amount and rainfall intensity. What is the difference between rainfall amount and rainfall intensity, Manashi? What is that?
The water amount where we get is the amount of rainfall.
Yeah.
The intensity means the amount of rainfall in a particular time that we are getting.
What is the unit for the intensity?
It's the millimeter per hour.
Yeah, very good. Millimeter per hour, right? That's the intensity. So we will see all such processes later in detail, right? So first one, rainfall characteristics. Then we will talk about wind effect, right? Then of course we will talk about some other miscellaneous climatic factors which are responsible for that. Please make a note on this. Abhishan, finished? Yes?
No, sir.
Abhishan, you have got a responsibility. Please have a chat with your newcomers, right? Because we are in a hurry to expedite this process. So please talk to your newcomers. Then let me know what they say, right?
Okay, sir.
Abhishan, you just talk to me after this class. Okay, you know my number, yes?
Yes, sir.
Yeah, please call me, right?
Okay, sir.
Okay. Yeah, sure. You can do it, Deepika. You can leave. Yes. Right. Midushana, finished?
Yes, sir.
Finished or not finished?
Finished, sir.
Okay. Manashi, finished?
Yes, sir.
Right. So I will discuss this one again next time when we meet, right? Thanks a lot for coming. That's enough for the day. Have a good day ahead.